This is Unit 13, and our learning target today is I can calculate the surface area of a pyramid. So here we have a variety of pyramids. What's important to note here is that a pyramid is named by its base. So for example, this is a triangular pyramid because the base is a triangle. And here we have a hexagonal pyramid because the base is a six-sided polygon called a hexagon. So it's a hexagonal pyramid. Some of the vocabulary that we're going to talk about today is pyramid, base, height, lateral face, and vertex or apex. We see a visual here of a square pyramid. I know it's a square pyramid because it has 8 inches on each of the sides of the base. So we have a square base. All of the sides, or the lateral faces, meet at the very tip top at a point called the vertex, or the apex. Again, in this pyramid, in all pyramids, we have triangular lateral faces. So for a square pyramid, we would have 4 triangular lateral faces because each triangle meets with one side of the base. So we have a lateral face here, a lateral face here. On the back side, here's another triangular lateral face. And here, lastly, is the last triangular lateral face. This is the slant height. So from the apex down perpendicular to the side of the polygon that's in the base, that makes a perpendicular cut, so it is a right angle. That's called the slant height. So here we have a rectangular pyramid, which in this case is also a square pyramid because each of the sides is 6 centimeters long. And we now know that the slant height is 12 centimeters. Sometimes it's easier to understand a 3D shape if we unfold it. So this is what we call a net, and this square base is from here on our 3D model. And then here we have the 4 triangles that all meet at the apex. So we know the slant height is 12 centimeters, and we know that each side of the base is 6 centimeters. So let's calculate our surface area. Here is our net. To calculate surface area of a pyramid, you need to calculate the area of the base and then add it to the area of the triangular sides, or the lateral faces. So first let's look at the base. Ours is a square, so the area of the base will be length times width. So 6 times 6 equals 36 square centimeters. So our base is 36 square centimeters. For our triangles, or our lateral faces, we're going to use our triangle formula. So 1/2 times the base times the height. So 1/2 times 6, because we know 6 is the base of the triangle, and the height is 12 centimeters. So we're going to multiply 1/2 by 6 by 12 to get each triangle has a surface area of 36 square centimeters. Now we have 4 triangles. So if we multiply 4 times the 36, we find out that the total lateral face area is 144 square centimeters. To finish, we need to add our base, the 36 square centimeters, with our lateral faces of 144 square centimeters to get a total of 180 square centimeters for our surface area of this pyramid. Now there is a shortcut for finding the surface area of a pyramid. So we know that this net for the square pyramid has a surface area of 180 square centimeters. The formula for surface area of a pyramid is the area of the base, which is the same as we used, and then we're going to add that to 1/2 times the perimeter of the base times the slant height. So the reason we can use this formula is, here are our purple triangle lateral faces. If we line them all up along the bottom, we're going to get the perimeter of the square. So we're going to start here. We'll go through one triangle. Here's the other triangle. Here's the other triangle. And here's the last triangle. So this black perimeter is now located right here on our diagram. If we look at the slant height, that's going to be our perpendicular line, and we know that's going to be 12 centimeters. So this is the area of a parallelogram. We're going to multiply the slant height, which is also the height, times the base, which is also the perimeter. And if it's a triangle, of course, we need to find half of it because the blue triangles don't have anything to do with our square pyramid. So we're going to find just the purple triangles. So we know that 6 times 6 is 36. We're going to multiply 1/2 because we only want to know the purple triangles, not the blue ones. And 24 is our perimeter. So all the way around the square, the perimeter is 24 centimeters. And 12 is our lateral face height, or our slant height. So we get 36 plus 144, which is exactly what we got when we just did the area of the triangle sides. And so we get a total the same of 180 square centimeters. So just to review briefly, the formula for the surface area of a pyramid is the area of the base. Notice it's a capital letter for a variable, and that means it's a calculation by itself. So we're finding the area of the base for our capital B. Then we're going to add it to 1/2 times the perimeter of the base. Again, it's a capital letter because it refers to the perimeter of the base, a calculation on its own, and then times the slant height from the lateral surface. So here's an example for you to try. Again, you have a square pyramid. It says that there's one little dash on each side, and this side is 5 centimeters, so each of the sides is 5 centimeters. It's a square pyramid, and the slant height is 8. So go ahead and calculate the surface area of the square pyramid. And lastly, before you finish, tell me something that you learned or were reminded of, and a question that you have.